Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to motion in a straight line, basic description of motion, the parameters associated with it. So we have discussed in the previous videos basic theoretical concepts and mathematical formulas related to motion in a straight line, such as distance, displacement, speed, velocity, acceleration, and its graphical analysis. So now we'll be solving some problems, some questions related to those concepts. So again, we will be going step by step, okay, starting with simple straightforward problems, then gradually we'll go a level up to intermediate ones, then advanced problems, step by step. No need to worry, we'll discuss a lot of questions related to it. Okay, so this is the first question, and it has been given that a railway train, it takes 8 hours to cover a distance of 400 kilometers between two stations. What is the speed of the train, assuming it to be uniform? So here we have two stations. Let's say this is station 1 and there is railway track. Because it has been given, it is distance, not displacement. That's why this is station 2. Total distance is how much? 400 kilometers. That is the total distance covered. Okay. Total time taken is 8 hours. That is the total time taken. Now we know that speed, the formula of speed is total distance traveled or covered divided by total time taken. This. For velocity, it is displacement by time. Here it is, as distance is involved, so it is speed. If it would have been given displacement, then velocity would have come into play. Okay, so always be clear about speed and velocity. Okay, so here total distance 400 kilometer. This is 8 hours. So this is how much? 50 kilometer per hour. This is one way of expressing it. Another way is by converting it into meter per second. So it is 50 into 1000 meters. 1 kilometer is 1000 meters, and 1 hour is equal to 60 minutes. Then 1 minute is 60 seconds. So it is 60 into 60 seconds. So this will be, if we calculate it, it will come around 50 into 1000 by 3600. It is coming around 13.89 meter per second. Okay, this. So if in the solution, if it is asked to find the result in kilometers per hour, then this will be the result. If it is given to find it in meter per second, this will be the result. Okay, so very simple, straightforward question, and we determine the solution. So here is another question. So it has been given to calculate the time taken by light emitted from sun to reach the earth's surface. Okay, and some data has been given. The velocity of light, as we all know, 3 into 10 to the power 8 meter per second, and distance between sun and earth, it has been given 1.5 into 10 to the power 8 kilometers. Okay, so here again, basic application of the formula of speed. We all know speed is equal to total distance covered by total time taken. Okay, this. Now here, this data has been given, total distance covered, which is this distance between Sun and Earth, 1.5 into 10 to the power 8 kilometers, and speed of light, that is given 3 into 10 to the power 8 meters per second. So all we have to do is determine this total time taken. So here time will be simply distance by speed, which will be equal to, we'll convert it in meters. Okay, this upper thing, the distance 10 to the power 8 to 10 to the power 3 meters, and speed, which is 3 into 10 to the power 8. So that it will be the result. Let us calculate. Okay, 1.5 into 10 to the power 11 by 3 into 10 to the power 8. Okay, so it is coming around, yes, 500 seconds. Okay, this. So if we want to calculate it in terms of minutes, it will be 500 divided by 60, because 1 minute is equal to 60 seconds. So it will be somewhere around, I think, 8.33 minutes. That is the time. So if it is given in the question specifically to calculate the result in terms of seconds, this will be the answer. And if it has been given to express it in terms of minutes, this will be the answer. And if it has been further said to calculate it in terms of hours, then it will be 500 divided by 60 into 60. Okay, 1 minute is equal to 60 seconds, 1 hour is 60 minutes, so it will be 60 into 60, that one. Okay, that result, this much hours. Okay, so no matter in which unit is asked, this will be the formula. All you have to do is just change around to get the answer in the required units which has been asked. Okay, so here is another very simple question based on the formula of speed. Okay, so here is another question on basic description of motion. So here it is given that a gun is fired from a distance of 1.2 kilometers from a hill, and the echo of the sound is heard at the same place after 7.1 seconds. Calculate the velocity of the sound. So basically what it is saying, that let's say a gunshot is fired, let's say from here. Okay, so as a result of which sound waves are produced. Okay, so those sound waves, after striking with an obstruction, it may be another hilltop there, it returns back. Okay, it returns back. Okay, so this total distance, okay, this between the obstruction and the source of the sound, this distance is 1.2 kilometers. But the sound covers double of this. First, starting from here, then it strikes the obstruction here and it returns back. This is the total distance, which is 2 into 1.2 kilometers, 2.4 kilometers. That is the distance covered by the gunshot sound. This. and here when it reaches back to the source, okay, the time lapse is 7.1 seconds. Okay, time taken is 7.1 seconds. The sound waves get reflected from this obstruction and they return back like this after striking the obstruction here. So here the velocity of sound here will be or we can say the speed of sound because it covers a straight line distance here. Same thing, distance by time. Okay, the speed of the sound is distance by time. Here it will be equal to 2.4 into 1000, we'll express it in meters per second, and this is 7.1. Okay, so this is equal to, if we calculate, it is coming around 338 meters per second. Okay, that is the speed of sound. This. Okay, this is the result. The speed of the sound waves, the gunshot sound is 338 meter per second. So always here, always understand this concept that the sound originating from a source, it strikes an obstacle in its path, gets reflected back from there and travels back to the source where the echo sound is heard. So the total distance covered by the sound is double the gap between the source and the obstruction. That's why this is very important, this part. 2 into 1.2 kilometers, which is the total distance covered by the gunshot sound. Okay, this.